Hey everyone, how's it going? Today we're gonna be talking about finding the general solution for first order PDE with constant coefficients. Then we're looking for solutions to equations that look like this, where a and b are constants. That means any number. So here's an example what that equation might look like. Here's another example. All right, so there is a general formula to finding the solution to these types of problems. The formula looks like this, where your function that satisfies this equation is a function where you have b of x minus a of y, where b and a are just the coefficients that you are given. So you basically just plug in -7 for b and 4 for a. But in this video, we're going to be talking about how to derive that equation. That means how do we get from this to that. All right, we're going to be using what's called the coordinate method. There's other methods. There's the geometric method, but this one I'm focusing on the coordinate method. Now, how do we get from this to this? Let's find out. First off, you need to change variables, called the change of variables method. Now, you might remember from Calc 3, from multivariable calculus. First off, we can say to find the solutions, we let x equal ax plus by, and you let y prime equal bx minus ay. I know it looks mysterious, but trust me, it'll work. And PDEs are kind of like that. You kind of just have to trust it. Now, what you want to do first is change the variable. So instead of working with u of x and u of y, you have to work with the x prime and y primes. So let's do the change of variable formula. So the change of variable formula, again, you start off, we know that u of x is equal to du of x. Now to change the variables, to do the following. Okay, so first thing we need to do is change our derivatives from x and y to x prime and y prime. Let's start with u of x. So we know that u of x is equal to del u del x. Now to use the change variable formula, or to change variables, we have to use the following. You can do this twice, one for u of x and also for u of y. If you had a third variable, you have to do it for u of z. So let's see, that's going to be del u del x del u del x. Now this would be del x prime del y prime del y prime. Now, the first one we do not know because we do not have the function u. That's what we are looking for. So we do need to first go ahead and leave that as is. You can leave it as u of x prime. Now this one, the partial derivative of x prime with respect to x. So here's x prime. You're taking the partial derivative of it with respect to x. So that means anything with the y is treated as a constant. So that's a constant that goes away. We are left with just a. So that's just a. Next up, same thing as well. We do not know what u is, so we leave it as u y prime. And then derivative of y prime with respect to x. So here's y prime with respect to x, so it's just b. Next up, we need to find. So u of y is going to be equal to partial del u del y variables. Let's see, partial u. Can be with respect to x prime and respect to y prime. See, leave this one as is, just as same reasoning as before. So it's going to be u of x prime. It's going to be derivative of x prime with respect to y. So it's going to be just b. It's going to be just b, so times b. And the next one we have, let's see, plus u of y prime. And then derivative of y prime with respect to y, so that's just negative a. It's negative a. And what do we end up with at the end once we simplify some things? We end up with the following equations. We're left with those two equations. We're going to plug them back into our original equation, which is AUX plus BUY. Let's move that up a bit. So what do we get? So there's our equation. We don't need this anymore for now. Let's move it here. So we're going to substitute u of x with this expression, u of y with that expression, and we get the following. Okay. Now from here, it is just a lot of algebra. You need to distribute and then combine like terms, cancel out certain terms. So we're going to distribute a into each item inside of here, and we're going to distribute b into each item inside of here as well. And we end up with the following expression. All right, so you have that expression. Notice that I wrote these in green because once you multiply this and this, these two will actually cancel out because they are opposites. So that goes away, that goes away. And now we are left with a squared u x prime plus b squared u of x. Should be x prime equals 0. They both have u of x prime in common, so we can factor that out as well. So we're left with this. Now, from here, you can divide by a squared plus b squared. In case you're wondering, well, how do we know that that's not equal to 0? There is a quick explanation for that. Once you square a number, it is non-negative. So that means these are both non-negative, so they're positive numbers. So if you add two positives, you can't get 0. Now, the only problem is if they're both 0. Right? Like, well, what if they're both 0, right? Because that's still a non-negative number. Well, if they're both 0, because that's the only way you can get 0 here. If they're both 0, then that means that this would be 0 and then that would be 0. And then we would get the trivial solution. It would be like, well, why we're doing this in the first place if this is 0 plus 0 equals 0. So that's how I know that this is non-zero. So you can divide both sides by a squared plus b squared. So let's take care of that this moment. Right, so we can divide both sides by a squared plus b squared. That goes away. And now we're just left with u of x is equal to 0. U of x prime is equal to 0, actually. So u of x prime is equal to 0. So what does that mean? That means that we took the partial derivative of a function u, and we got 0. So now if we want to integrate, we either get a constant or we get a function with respect to y prime. Right, so if we're actually integrating this, right? If we integrate, we would get prime is equal to 0. If we integrate, that means we're going backwards. So that means the only way we could have gotten 0 is if we differentiated with respect to x prime, and the items were either constants or that they were a function of y prime. So that means if we integrate, u is actually a function of y prime, and we saw, or we stated earlier that earlier we said y prime is equal to bx minus ay. So that means u of xy, our function, is actually equal to f of bx minus ay. And that's how we arrive to that solution. So that's how we come all the way from the general solution for a PDE with constant coefficients is actually equal to f of bx plus a minus ay. Hope this helps.